Okay. Hello, Olivia.
Hello.
Thank you for your time. So what I'm going to do in this interview is I'm going to show you 3 equations,
Okay.
which I would like you to solve. And as you solve them and as you write your working down, can you please talk to me through what you're doing, what thoughts you've got as you're doing it, and then I'll ask you some other questions.
Okay.
Okay. All right. So there's the first equation.
Okay.
Can you please solve that?
All right. So just explain how what I'm doing.
Yeah.
So I know that I'm supposed to move the smaller x to the other side so that just make it easier. So because that's small, because it's -4, I did the opposite. So I add plus 4x to both sides of the equation, and then while I'm at it, if this is going to have the x, this should have the other. I forgot what it's called. But that means I did the opposite again. So to this side I do +3, and over here is also +3. So here I'll have 6x because that's a bit wonky. Because 4 + 2 is 6, and then here it would be 6x is equal to 18 because 3 + 15 is 18. And then to get x by itself, you divide both of the sides by 6, and then you're left with x is equal to 3.
Excellent. Thank you. That was very good. Very clear explanation.
Great.
Okay. So is that the way you normally solve equations like this?
Yes.
Any other ways you've solved equations like this?
Sometimes I've done it backwards where I've moved the 2x over to this side, but from trial and error I've just found this way just works a bit easier.
Okay.
Just to avoid as many negatives as possible.
Okay. And how do you know if you got the right answer? How do you know if you're correct?
Either I check the answers or I sub it back in if I'm in test.
Okay, so when you say check the answers, what do you mean?
Oh, I check the answers in the textbook.
Right, look at the back of the book.
And just check to see if the answers are correct.
Okay. And let's say you looked at the back of the book and the back of the book said, you got 3. So let's say you looked at the back of the book and the back of the book said x equals 2. What would you do then?
I would try and solve the equation again, see if I messed up. If it gives me 3 again, I might try subbing 2 into the equation. And if that still doesn't work, I'd ask my teacher or a friend if the teacher's busy.
Very good. Now, what does the x in an equation like this mean?
It's an unknown value.
Okay. And what does the equation mean?
It's I don't know how to answer that as much. Like it's a way to find out what the unknown value is. Like you need to solve it. It's a balanced equation, so everything on one side has to be the same as the other, and you need to find what x is so that that's true.
Okay, great. Thank you very much. Here's another equation.
Okay.
Can you solve that one, please?
Yeah. Just from habit, I'm used to having the x's on the left, so I deduct. Oh, I can already see this is going to be really weird. Deduct 2x from both sides, and deduct 3 from deduct 3 as well. So like, I'm moving this x over here and this one over here, and then that would be 0 equals 0. I'm honestly not entirely sure now what to do. I'm actually not entirely sure now. Well, if x would have to equal 1, I think, because it would have to equal 1. I'm not entirely sure how I got that, but I realized if they're equal, then x would have to. But I'm not quite sure how to show the working to solve that. Sorry.
So why do you think x equals 1?
Because if 2 plus 3 is the same as 3 plus 2, then could x have I'm beginning to think x could actually have any value, because if they're balanced equations, I don't think that's the right word. X could equal, I think, anything, because if that was a 1, it would be balanced. If it was a 2, it could be balanced. Because if that was a 2, that'd be 4 plus 3 is 7, and then 3 plus 2x, if that was a 2, that'd be 7 again. So it could actually take a range of values, right?
Okay, so you said before that the equation was balanced.
Yeah, I don't think that was quite the right word.
So what do you mean when you say that?
It's equal on both sides. Maybe balance might be actually the right word. I'm not quite sure, but if they're the same on both sides, regardless of the of what x is equal to. So this side and this side are both equal, which is why I was saying they're balanced. And I'm not quite sure if that's the right word, but yeah.
What do you mean when you say they're both equal?
They're equal to the same value. So if that was a 1, 2 plus 3, 2
Right.
plus 3 plus 2, 5, they're equal values.
Okay, great. Thank you. And here's the last one.
All right,
Can you solve that equation?
I hope so. Okay, so I'll deduct 2x from both sides, and then because that's negative, I'll add it. So plus 3 and plus 3. So here I'll have, oh god, I don't know how else it's gonna go. I'll just give the coefficient of x equals 6, which means I've done it wrong, which means it might be, oh I know. Oh. Even if I did it the other way, I'm not sure if it would work. Because if I added that, it would be, if I did it backwards, it would be 0x is equal to negative 6. I'm not entirely sure with this one, actually. I feel like I've probably been asked to solve a similar question, but right now the answer is escaping me because it's yeah, I'm not sure, because if they're the same value, then that would mean that this will, no matter which way I solve it, it will always be 0x. And 0, and no matter what value x is, it will end up being 0 is equal to x, which means it isn't correct. And then even if I divided both sides by 2 first, which isn't even the correct way to do it, then I'd still have the same issue, because then it'd still be x minus x.
So what's your solution, do you think, to this one?
I'm not sure if I have a solution to this one.
Okay.
I can't figure out the answer to this one. It annoys me a lot. I don't know how to solve this. Yeah, no matter what way I look at it, it's always going to be 0x is equal to 6 or negative 6, depending on which way I solve it.
Mm-hmm.
So I'm not quite sure. I don't think there's a solution to this one.
What do you mean?
I don't know if, like, I'm not sure if there's an actual I don't think it's actually possible maybe to have a solution to this question, just because of the way that it's negative 3 and then the 3 there. I can't think of any number that would even just going through trial and error, I can't think of a number that would I forgot the word, but make this equation true. So I'm not sure if there is an answer to this question.
Okay. Do you want to say anything more about it?
No.
Okay. All right. So let's have a look at the second and the third one again.
Okay.
Here they are. I'm wondering if you can think of any other ways that you might solve equations like this, apart from using your collecting like terms procedure that you've used.
If the 3, for instance, was a 4, there would be a chance I could try factorizing it and seeing if that could work, because then it'd be 2 bracket x plus 2. But even here, I suppose I could have done x plus 1.5, but I would have ended up coming back to 0 is equal to 0 again. So it would have just been more steps to reach the same conclusion.
Okay. What about, are there any ways that you could solve these equations without using algebra?
Not that I can think of, really. I can't really think of any ways to solve these without using algebra other than trial and error. And that...
Oh, trial and error, like substituting numbers
yes,
in.
so just thinking, oh, could 1 work, could 2 work, could 3 work?
Mm-hmm.
But then when it gets to, if the answer was 47, for instance, that would end up being a very tedious way of doing it.
Right. So you can't think of any other ways apart from algebra and subbing in?
Correct. Yeah, I can't think of any other ways.
Okay.
They're the only two I ever used to solve these sorts of equations.
Okay, great. Thanks for your time, Olivia.
Okay.
That's wonderful.